New Claude Code agent update is insane. You're coding with one AI agent while other developers are building with entire teams. You're waiting for tasks to finish one by one while they're running everything in parallel. 6 days ago, everything changed, and most people have no idea this even exists yet. On February 5th, Anthropic dropped agent teams for Claude Code. Instead of one AI assistant, you now get multiple Claude instances working together on your codebase at the same time, each one specialized, each one coordinating with the others. By the end of this video, you'll know exactly what this is, how it works, and how to set it up yourself. Let's get into it. Let me explain how this actually works because it's different from what you might expect. When you enable agent teams in Claude Code, you're not just making copies of the same agent. You describe what you need in natural language. Claude figures out the team structure. It creates a lead agent that coordinates everything. Then it spawns teammates. Each teammate is a separate Claude Code instance with its own context window. Each one loads your project context, your Claude.md file, your MCP servers, your skills. They work independently, but they're connected through a shared task list and a messaging system. The lead agent breaks your request into tasks, assigns them to teammates, monitors progress. The teammates claim tasks from the shared list. They work on their piece. When they need input from another teammate, they message them directly, not through the lead, directly peer-to-peer. This is crucial. It's not a hierarchy where everything goes through one central agent. It's a team where members coordinate as equals. Now, let me be clear about the difference between agent teams and something called subagents, because people get confused here. Subagents exist within a single Claude Code session. The main agent creates helper agents for specific subtasks. Those helpers do their work and report back to the main agent, then they disappear. The main agent stays in control the whole time. Think of it like a manager delegating work. Agent teams are fundamentally different. These are multiple independent Claude Code sessions running in parallel. No single agent is in charge of everything. They coordinate as peers. Each has its own goals, its own context window, its own workspace. They work together to achieve a larger objective. This matters for complex projects because you're not bottlenecked by one agent making all the decisions. Multiple agents can explore different approaches simultaneously. Link in description. So how do you actually set this up? You need Claude Code installed. Then enable agent teams by setting an environment variable. Claude_code_experimental_agent_teams equals 1. Set it in your shell environment or in your Claude Code settings.json file under the env block. After that, just tell Claude what you want in natural language. Claude creates the team, spawns teammates, sets up the shared task list. No YAML configs, no manual orchestration. Here's a real example from the documentation. Someone building a CLI tool asked Claude to create an agent team to explore it from different angles. One teammate focused on user experience, one on technical architecture, one playing devil's advocate. Claude created the team, gave them a shared task list, had them explore the problem, then synthesized their findings. The person didn't have to manage any of that coordination manually. Another documented example. A developer asked Claude to use a team of agents for quality assurance on their blog. The blog was running locally. That's all they said. Claude verified the site was running, created a team called Blog QA, broke the work into 5 tasks, spawned 5 agents all using Sonnet to keep costs down. Each agent tested different aspects: accessibility, SEO, HTML structure, image optimization, performance. They ran in parallel, found issues, reported back. The lead synthesized everything into a prioritized QA report. The whole process took about 3 minutes. 5 agents working simultaneously instead of one agent checking everything sequentially. Now, let's talk about the big example that shows what's possible at scale. Nicholas Carlini, a researcher on Anthropic's Safeguards team, ran an extreme test. He tasked 16 Claude agents with writing a Rust-based C compiler from scratch. The goal was to make it capable of compiling the Linux kernel. This is not a simple project. Over nearly 2,000 Claude Code sessions and $20,000 in API costs, the agent team produced a 100,000-line compiler. It can build Linux 6.9 on x86, ARM, and RISC-V architectures. It successfully compiles major software projects like QEMU, FFmpeg, SQLite, PostgreSQL, and Redis. It even compiles and runs Doom. This took 2 weeks with minimal human intervention. Different agents specialized. One handled parsing, another worked on code generation, another focused on optimization. Some agents critiqued the design from a Rust expert perspective. Others wrote documentation. They coordinated through a shared task list using file locking to prevent conflicts. When one agent finished a task, it pushed changes and cleared its lock. Other agents pulled those changes and continued their work. Is the compiler perfect? No. The code quality is decent but not expert level. The generated code isn't as efficient as GCC, it has limitations. But this demonstrates what's possible with coordinated AI agents working in parallel. A human team would have taken months to build something like this. The AI team did it in 2 weeks for $20,000. The lead breaks your request into tasks and assigns them. Teammates claim tasks from the shared list. When a task has dependencies, it blocks until the dependency completes, then automatically unblocks. If the backend teammate finishes API endpoints, they message the frontend teammate directly to share the schema. No round trip through the lead. You define the outcome. The team figures out how to make it happen. But I need to be very honest about the limitations and costs. This is experimental. It's not perfect. Agent teams work best for well-defined projects with clear boundaries. If your scope is vague or keeps changing dramatically, agents can get confused. They need concrete goals. Coordination isn't always flawless. Sometimes agents duplicate work. Sometimes they make assumptions that don't align. You need clear role definitions. Make sure each agent knows their specific responsibility. Check in periodically to verify alignment. Cost is a major consideration. Running multiple agents at once means significantly more API calls, more token usage. The C compiler project costs $20,000. For most people, that's way too expensive. Agent teams can easily cost 5 times more than using a single agent because you're running multiple Claude instances simultaneously. For simple tasks, this is total overkill. Save agent teams for complex projects where parallel work actually provides value. There's also more upfront planning required. You can't just jump in. You need to think about team structure, define roles, set up coordination. That takes time. But once configured properly, the productivity gains can be worth it. Agent teams have known limitations. No session resumption right now. If a teammate crashes, you can't easily resume where it left off. Same file editing causes conflicts. If 2 agents edit the same file, you get overwrites. You need to structure work so each agent owns different files. Tasks with heavy dependencies end up running sequentially anyway, which defeats the purpose of having a team. Let me share some best practices based on what developers have documented. Start small with 2 or 3 agents, not 10. Define clear roles with no overlapping responsibilities. Use descriptive names like backend agent and frontend agent, not agent 1 and 2. Choose split pane mode for larger teams so you see everyone working simultaneously and catch issues in real time. Use delegate mode for large teams by pressing Shift plus Tab. This restricts the lead to coordination only so it doesn't jump in and code instead of managing. Intervene when needed. You're still the project lead and iterate on your structure as you learn what works. Now let's talk about real-world use cases. Web apps with 1 agent on backend, 1 on frontend, 1 on database, 1 on tests. Data pipelines with agents for collecting, cleaning, storing, and visualizing. Content systems with agents for research, writing, editing, and SEO. Testing frameworks with agents for unit tests, integration tests, performance tests, and security scanning. Code review with 3 agents each focused on security, performance, or test coverage instead of one trying to check everything. Bug investigation with competing hypotheses where agents test different theories in parallel. Cross-layer features where agents own front-end, back-end, and infrastructure independently but coordinate on interfaces.